Hi friends, let's have a look at problem 2848, points that intersect with cars. In this video, we are going to explain a solution based on the strategy of sorting and linear scan. So here our purpose is not to solve this specific problem, but to point out or emphasize that this problem actually is an important prototype problem, that is the interval merge type. We actually have a playlist which contains analysis of such problems. So it contains a number of problems selected from LeetCode. You are welcome to check out that. So with that said, let's look at the problem here. So we are given a 2D integer array called nums, and each element contains a start and end, right? Start is the starting point of the car, and end is the ending point of the car. So we want to return the number of integer points on the line that are covered with any part of a car. So here we have two examples. In the second example, so we have 1, 3, 5, 8, right? So these two intervals are separated or disjoint. Therefore, the points covered, let's do the count, that will be 3 minus 1 plus 1. So in other words, we count 1, 2, 3. So this gives us 3. And 5 to 8 gives us 8 minus 5 plus 1, that is 4. So 3 plus 4 together we get 7. That's the output for example 2. And for example 1, so if we sort this nums list according to the starting point or the first component of each, let's regard them as closed interval. So according to the first component then. So we are going to have 1, 5, 3, 6, and 4, 7, right? So if we examine the first two intervals, 1, 5 and 3, 6, so they can merge as 1, that is 1, 6, right? Then if we look at 1, 6 and 4, 7, they actually overlap again. So they can be merged as 1, 7. So the number of points covered is 7 minus 1 plus 1, that is 7, which is the output for this example. So with that said, we are ready to look at the coding part. However, let's look at the constraints. So here the length of this list is very small. It's bounded above by 100. So essentially we don't need to think too much about the term complexity. However, so here we are going to give a algorithm, and basically an n log n algorithm, where n is the length of this nums list, because the main part will be the sort, and then we are going to do a linear scan, right? So basically from the name of the strategy, we can actually interpret the term complexity. So with that said, let's look at the code. First, let's do a sort. Here, I'm not going to specify a sorting key, because sorting according to the first component of each interval, from small to large, will be sufficient for our purpose. So with that said, I'm going to get all the intervals, merged intervals, though this is not an absolutely necessary. So for explanation purpose, it might be good. So we're going to have intervals. It contains the first one, nums 0 after sort. And then we are going to do a linear scan for I in range 1 to length nums. Then first I'm going to get this S and E, this current interval, so nums I, just for convenience. And then we compare the current interval with the top element in the intervals. So if they do not have overlap, so we are going to append the current interval to the list or stack. And if they have overlap, we are going to pop the top element and merge that interval with the current interval. So we do it in a continuous fashion. So if S is greater than intervals -1, this is the top element, the end, right? If this is the case, it means the current interval as a top interval in the intervals have no overlap. So we are going to directly append the current interval to intervals. That is nums I, right? This is the one case. Otherwise, so the two intervals have overlap. So we need to get, so previous S, previous E will be intervals pop, right? And then what we want to do, we want to go intervals append. So the interval we are going to append, so the smaller start will be previous s, right? Because we have sorted according to the first component. And then the end will be max, previous e, and the current e, right? So this way we are going to have an out merged interval. So let's print out this before we prepare the return. So this might be helpful for digest. So for the first example, we are going to get 1, 7, right? So this will give us result 7. Because 7 minus 1 plus 1, that is 7. For the second example, so it will return the same thing for the intervals, right? So we are going to have 1, 3 and 5, 8, right? So with that said, we are ready to get the return. So this is nothing but a list comprehension, right? So we do sum or iterate, right? See, what we want to do is s, not s, e minus s plus 1 for s, e in intervals, right? So this will give us the result. Yep, that is. So now let's do a check for the general case. Yeah, it passes all the general cases. So that's basically about it for this specific problem. So as we mentioned, so this solving this problem is not our sole purpose. Our main purpose is to emphasize that this easy problem, as marked by leetcode, actually is very important. It's a great example for an important class of problems, that is the interval merge type problems. So as we mentioned at the beginning, so we have a playlist which contains a number of such problems. It's actually good to check out and practice. So with that said, that's about it for this problem. Thank you.